This is our introductory video on pH. So as far as what we need to be able to do with pH, we'll talk about it a lot in biology class in terms of how it impacts enzymes and how maintaining pH is a necessity for maintaining homeostasis. And so we'll look at some mechanisms that living things, including humans, have to actually maintain pH. Now, pH itself is actually an acronym. It stands for percent hydronium, and that has to do with the chemical composition of acids and bases. What this video is essentially going to do is it's going to talk us through the chemistry components of the pH scale. So why are acids acids? Why are bases bases? So what chemical differences separate these two classes of chemicals? So I want you guys to see if you can come up with an example and an example of a base. So acids and bases, as we just saw, are not totally new terms for us. What will be new for us, though, is looking at them in terms of their chemical composition. Specifically, we are going to look at what are known as Bronsted-Lowry acids and bases. Next year in chemistry, you guys will talk about Lewis and acids and bases as well, and you'll talk even more about the Bronsted-Lowry ones. So down at the bottom here, we have the three gentlemen who are responsible for our different functional definitions for what it means to be an acid and a base. What's really important for us to realize is that acids and bases were not discovered by these gentlemen down here. Acids and bases have been around, or the acknowledgement that there are different substances that behave a certain way, and we call these acids. And then we have another class of substances that behave a different way and call these bases. This has been known for thousands of years and studied. It was only when technology got better and we were able to look at the chemical composition of what we classify as an acid and what we classify as a base that we noticed that there's an actual difference in their chemistry, and we can explain those differences in terms of their chemistry. So the actual chemical component or difference has to do with when you mix substances in water, depending on what type of ion they form, so what charged atom or atoms they release, that will determine whether or not something is an acid or a base. So for example, an acid, like your citric acid, which you would find in your lemons, when you mix them in water, what they will do is they will form hydrogen or H+ ions. It is those hydrogen ions, when they form in water, that gives acids some of their behaviors and some of their chemical properties that we see. Contrary to that, bases, when you take these substances and mix them in water, what they form are OH- or hydroxide ions. And it is the formation of those ions that give your bases their behavior or their specific properties. Some new terminology, or old and new. If you look on your sheet, questions 1 and 2 ask you to describe what these adjectives would mean when they are used to describe a substance. So acidity refers to, good, those are your acids. And alkalinity, this one's a little less intuitive, but yeah, that one refers to your bases. So when we refer to an alkaline substance, we're referring to something that has basic properties. So in order to understand, again, since Bronsted-Lowry definition is based on what ion you form in water. So if you form a lot of H+ or hydrogen ions, you're an acid. Form a lot of OH- or hydroxide ions, you're a base. What we need to understand is, or predict, is how things are going to ionize. So how they're going to break apart in water into charged particles. So if you look right here, I've shown you guys the ionization of a water molecule. So you've got H2O starting out, and as it ionizes or dissociates to break apart, you end up with one hydroxide or OH- and one hydrogen or H+ ion. As far as which one ends up negative and why it's negative versus which one's positive, this is all information you guys will cover next year in chemistry. So again, ionization is just the process of forming ions, and it's how we determine whether something's an acid or a base. So again, can't emphasize this enough because this is part of what you're going to need to be able to do. So if you see H+ ions are being formed by a substance, that makes it an acid. If you see OH- ions are being formed by a substance, or hydroxide ions, that makes it a base. What we notice with the ionization of water is that when water breaks apart, it forms exactly 1 part hydrogen ion and exactly 1 part hydroxide ion. Because of that, water is at perfectly neutral, or 7 on our pH scale, because it's exactly 1 part acid to 1 part base, making it perfectly neutral. So what we're going to do now is practice ionizing a substance together, so looking at how it would break apart. For what you guys are going to need to be able to do in this class, I am going to tell you or identify where something is on this pH scale. So you will know going into it whether something is an acid or a base. You should be able to predict. If you know it's an acid, you should think, okay, what ion do I know it's going to form? So if you look at your sheet, it says that acids form H plus ions. So then you know that a hydrogen ion is going to form. Then you have to think, okay, what do I have left over in this substance? Because law of conservation of matter tells us that if your hydrogen is giving up an electron, then whatever atom you have left over has to be picking up that electron. So if we do this with hydrofluoric acid right now, you notice that in our diagram, hydrofluoric acid, when they're connected, looks like this. But when it ionizes in water, it's going to split apart. So you get H plus, which I knew I was going to get because it's an acid. And that means that my electron from this hydrogen went to my fluorine, so I end up with F minus. So if I had to ionize this or predict what ions I'll have, I'd know that I would get H plus and F minus. And it's this H plus right here, this hydrogen ion, that Bronsted-Lowry said makes this an acid. So again, when you guys do this on your own, you should be able to, based on knowing it's an acid or base, tell me at least one ion it has to form based on what ions acids and bases have. Now you guys are going to be asked to ionize on your worksheet or determine what charged parts two substances will break up into. So the two that I'm going to have you work with, and I want you to actually write these down on your chart, so on your worksheet, is for number 5, it's going to ask you to ionize HCl. So again, look at what we just did with hydrofluoric acid to figure out how that would break apart. And then the second substance you're going to be asked to ionize is NaOH, which is sodium hydroxide, but we're going to kind of have that be our stand-in for ammonia. So those are the two ionizing pieces that you need to do. What you guys are going to do now is work with a partner or by yourself if you would prefer to complete the acid-base worksheet. So it's the last page in your Intro to Chemistry packet. You're going to go through questions 1 through 13. Do these in order, because if you try and skip around and do bits and pieces, that's not going to make sense to you. You have to actually walk through each part. That's how the worksheet is designed. And again, for the ionization piece, come back, see how we did it with hydrofluoric acid, and that's what you need to do for those. All right, email me if you have any questions.